Welcome back, everyone. This is the lesson part 2 on implicit differentiation. So if you haven't seen part 1, please make sure to begin with that one. And here we're doing additional examples. So the question is to find dy dx in every one of the examples that will follow. And we don't have to solve for y. We learned last time if you have x's and y's all mixed together, you can use the implicit differentiation technique to get your y prime without having to solve for y. And the main approach was to remember to keep in mind that y is a function of x, even though we're not going to actually solve for y. So let's begin. Take the derivative of both sides with respect to x. Here we have 2x plus derivative of y squared with respect to x will be 2y y prime, where y prime is dy dx, right? On the right side, we have 5x times y cubed. I'm going to write it like the product of 5x times y cubed. And using the product rule, you write the first one as it is, times the derivative of the second, which is 3y squared times derivative inside, which is y prime, plus write the second one as it is, y cubed, times derivative of 5x with respect to x, that's 5. So again, let me collect my y primes on the left side. So we have 2y y prime, and subtract this term. So you have minus 5x. Actually, let's combine that as 15xy squared y prime. So minus 15xy squared y prime equals, on the right hand side, 5y cubed. And let's move this 2x from the left to the right by subtraction. So it'll show up as minus 2x on the right hand side. So we have all our y primes on the left, everything else on the right. So we're getting closer to solving for y prime. And of course, next we have to factor, right? Factor the y prime. So now we have 2y minus 15xy squared equals the same right hand side, 5y cubed minus 2x. And now to finish the question, let's just divide both sides by the quantity in front of y prime. So y prime equals 5y to the third minus 2x divided by 2y minus 15xy squared. Okay, so let's do another one. So I hope by now they're becoming more standard, not so confusing. Let's take a look at, okay, this was an interesting one. It's going to be a little bit more challenging. But the thing is, for this question, they only want you to take the derivative with respect to x and no need to solve for y. Okay, so basically you just have to do the first step here and you don't need to do the following steps. This is just going to give us practice about taking derivatives when the x's and y's are all mixed in together. Okay, first I'm going to notice that here you have y times e to the 3x. We're going to need to use the product rule, right, to take the derivative of that quantity. Then y cubed should be easy. On the right hand side, 5 sine x times y squared, or sine of x times y squared. So there the outside function is sine, and when it's time to take the derivative of the inside, that's where we're going to use the product rule. So let's get started. On the left hand side, to take the derivative of y times e to the 3x, let's begin with the product rule. So y times derivative of e to the 3x will be 3 times e to the 3x plus, write the second one as it is in that product, times the derivative of the first. So what is the derivative of y with respect to x? It's just like 1 times y prime, okay, or just y prime, plus, so that takes care of the product. That gave us 2 terms that came from the product rule. Now let's take the derivative of y to the third. That'll be 3y squared y prime equals, okay, so if a constant times something, the constant stays as it is. You have sine of a quantity, so the derivative will be cosine of the same quantity. So cosine of xy squared times the derivative of the inside, right? And the derivative of the inside is x times y squared. We need a product rule for that. So it's going to be x times the derivative of y squared, which is 2y y prime, plus, write the second one, which is y squared, times the derivative of the first, which is 1. So I don't need need to write it down. So there we have it. We have done the first step of taking the derivative with respect to x. And if the question said go ahead and solve for it, which I did not, I would have to distribute this 5 times cosine quantity over both of these, collect the y primes on the same side, etc., etc. But again, this one tends to be very, very messy, so at least I wanted to see if you could do the first part of the problem correctly. So one more example. Let's look at number 9 from our lecture notes. We have x times ln of y plus y to the 7 equals 2 ln x. And I need to remind everybody, okay, how do you take the derivative of ln of u, where u is a function of x? 1 over u times u prime, right? Where u prime is du dx. So as long as we remember that, this should be pretty straightforward. Let's begin by taking the derivative of the first term, which is x times ln y, by using the product rule. So we're going to have x times the derivative of ln y, right, which is 1 over y times y prime, plus the second quantity, which is ln y, times derivative of x, which is 1, plus the next term is y to the 7. The derivative of that is 7y to the 6 times dy dx, or y prime. On the right hand side, we have 2 ln x. What's the derivative of that? If you said 2 times 1 over x or 2 over x, you are absolutely correct. So we're going to follow the same principle as always, right? Since there's 2 y primes on the left, let me put them on the same side. And while I do that, I'm going to factor out the y prime from those two. So from the first one, we have basically x over y. And from the other one, 7y to the 6. There's a plus in the middle. On the right side, we already had 2 over x, and subtract the ln y. So it appears on the right-hand side. And it's gone. We subtracted ln y from the left. It disappeared on that side. Okay, so here now we have y prime factor. The rest should be easy peasy, right? So take y prime equals the right-hand side divided by the coefficient of y prime, which is x over y plus 7y to the 6. Now, we've seen a problem like this before, and one technique was to simplify this. You multiply top and bottom by a quantity so that you no longer have a fraction within a fraction. So that quantity typically is going to be the LCD of your little fractions. So like usually we multiply the denominators. So there's an x here, there's a y there, multiplies x times y. So let's multiply both the top and the bottom of this fraction by xy. That should clear all those little fractions. So we're going to distribute it. So 2 over x times xy, there the x's cancel, and we're going to have 2y minus xy times ln of y all over, what is x over y times xy? This time the y's cancel, right, and x times x is x squared. And xy times 7y to the 6, it'll be plus 7xy to the 7. So our final answer is 2y minus x times y times ln y, all on the top, divided by on the bottom x squared plus 7x times y to the 7. So yeah, it's a little bit messy, but it wasn't really that bad, right? The main thing you had to know for this question was your basic principle on how to differentiate the natural log function. And there was a problem I skipped over earlier. For that one, I think I'm just going to show you the answer. So please try it on your own. And when you get to it, when you're done with this number 3, again, that's a very standard one, just a few reminders. For the middle term, you're going to need to use the product rule, right? And don't forget, the right-hand side is just a number. Its derivative is going to be just 0. So we've done several of those, but please do it later on your own, and you can check it with the answer I'm giving you right here. Great, as always, just lots and lots of practice. Even though it looks pretty simple, so many small places one can make mistakes, and as always, the only way to eliminate those mistakes is seeing and doing lots and lots of examples. So see you next time.